Okay. So for homework, you were supposed to effectively do what we did in class last time. That is, you had already generated your public and private key using Coinbase. What we did last time is we explained this get HTTP method that we wrote, calculated our nonce, got our nonce, made a message, calculated our signature right here, built the body, passing it our public key, the signature, and the nonce that we use. This is the authentication thing we just talked about. Actually made the request, got the response, and spit the response out to the screen. And the response should be our current balance. Okay, so current balance in this account is 0.00030,379. Rich. Okay, most of you would have had 0.0 as your balance, correct? Almost as rich. Almost as rich. So
they still throw all the zeros on the end.
Oh, do they?
Yeah.
It's the same number of digits?
Yeah.
Okay, so that's kind of proof that we are hitting Coinbase and getting our account information. All right, any questions on the homework assignment? All right, so now we are talking to a third-party application using SHA-256 authentication, and we're able to pull some information. Now we got to go back and think about now that we're having this communication working, we got to think about the problem we're trying to solve. That is, we're at a store, so we have the customer and the store, and we want to have some sort of transaction. This transaction typically would take place in US dollars. Okay, but US dollars have a cost associated with them for most transactions if we're dealing with credit cards, right? We don't provide any benefit here doing this Bitcoin version of this for people who hand cash at the register. And I think when we started talking about this, we were talking about some examples of places that sometimes actually charge a premium if you want to use a credit card. Or the way they kind of usually show it is they give you a discount if you use cash. Same thing, right? So typically if we're using a credit card to pay by US dollars, there's going to be some fee that the store is going to have to pay. Anybody know what those fees typically are? What percent does a credit card company typically charge? 2.5%. Okay, so we'll throw this up there. So what we're trying to beat here is 2.5%. Now, I'll tell you right now, we're only going to be able to barely beat that using Coinbase. But that doesn't mean there aren't places like Coinbase that couldn't beat it more easily, or if we partnered with a place like this, and that'll make sense here in a second. So 2.5%. So if it's a $10 charge, how much money is Visa or MasterCard getting out of that? $10 times, you get a quarter, right? They're taking a quarter out of your $10 charge. So that's a quarter that's not getting into the store owner's pocket. All right, so this is the problem we're trying to solve. The fee that the store is getting less money from the customer because this guy in the middle, Visa, MasterCard, Amex, actually American Express is usually even higher, but let's just call them all 2.5% for our little example here. That's good enough. That at least makes our system slightly better, which is good enough for us. Okay, so these guys are getting this 2.5%. So we have this dude taking money in the middle, and we can call this a convenience fee. correct? The convenience of being able to pull out a credit card, swipe it, and now you're more likely to buy something from this store if it's easy for you to buy it. But the store has to either jack their prices or they're making less profit because you're sliding that credit card rather than handing them cash. So from consumers' perspective, if paying is still easy for us and the store can lower their prices because we like good deals, this is advantageous. So what's our solution to this? Our solution is we're going to turn let's draw the solution up here. So this is US dollars via credit card goes through American Express, which turns into US dollars back to the store. Minus 2.5%. Okay, this is that current model. All right, so we're gonna come up with a replacement model using Bitcoin. So the customer has US dollars in their possession, whether it's in a bank account, stored at CoinBase, whatever. We have US dollars at our disposal. Rather than pulling out a credit card, we're going to turn US dollars into Bitcoin. Bitcoin is then going to utilize the blockchain for a transaction, which arrives on the other end as Bitcoin. Now, just so we can compare apples to apples, so to speak, we will go ahead and have this converted back to US dollars on the store side. The store could always, the way the store is going to be most benefited here, assuming they trust Bitcoin, is to leave it as Bitcoin. But we're going to go ahead and convert it back to US dollars just so we have a good comparison here. Okay? So, using CoinBase, let's deal with this so we can put real numbers in there. To take US dollars and turn it into Bitcoin, Coinbase charges a fee of 1%. Okay? Realistically, if this was a real system, so thinking about it from a startup company perspective, let's say that we were going to take this idea, go to Coinbase and say, we think we want to revolutionize the payment industry. And Coinbase believes in us, let's say. Do you think we can negotiate that down to a much, much, much smaller percentage? Because Coinbase is likely going to be like, if every single transaction is using our system, why don't we talk about 0.2%? I'll take 0.2% of a million transactions rather than 1% of a couple, right? So basically what a lot of businesses have here is they are at the mercy of the credit card companies charging whatever fee they want. How many of you have an American Express? A couple of us, several of us. Have you ever run into a situation where you were at a place and you wanted to use an American Express and they didn't take it? It's relatively common because American Express charges even higher fees. Okay, so they can afford the most expensive commercials, because we always see the American Express commercials, right? But typically, every place that accepts credit cards will accept Visa and MasterCard, but only some accept American Express because it even has higher fees. So the idea here is that, oh, that was on my screen, not on, that was nasty actually. I don't even want to know what that was. So in any case, the store is at the mercy of whatever this credit card company wants to charge here, right? Do you think credit card companies could probably charge more than 2.5% and still get away with it? Probably could, up to a point. How often do you think people walk into a store and out of convenience will buy something because they have a credit card? When if you would only spend cash, you would think about the amount of cash you actually have on you and you wouldn't buy it because of that. I mean, often, right? It's so easy to just swipe the credit card and say that, but if you always had to hand them bills, hand them actual cash, you would think twice, right? Probably more than twice. It's actually a tactic. If you there's a author, Dave Ramsey. I think I maybe told you this before, but I couldn't remember the author's name. The guy's name is Dave Ramsey, and he has a book that talks about getting out of debt and blah, blah, blah. And one of his strategies is cut up your credit cards and spend cash everywhere you go, because then you'll feel it. When you run out of money, all of a sudden you're off the streets. But in any case, this has become, the idea of credit cards has become a way of life because of the convenience of it. And we also spend more money because of it. So if this store owner doesn't accept credit card, chances are their volume is also going to go down more than what they'd be giving up in that percentage. So as long as they have enough margin in here to absorb that percentage, if they're charging a 20% margin, well, now they're getting 17.5% margin because of the credit card fees. Well, 17%, 17.5% margin is pretty good compared to nothing, having just inventory, right? So these guys could probably raise the fees and get away with it. Why don't they? Why do you think the credit card companies don't raise the fees?
Go lower and
Yeah, it's almost like, you know, this is almost the example of a monopoly, right? We have three companies here that are all in competition with each other. Visa and MasterCard pretty much match each other's rates. And if one goes higher, the other one's going to stay low. All of a sudden, you're going to see a lot of people using more of that card than the other one, because you're going to have businesses that are going to really, they might stop. If MasterCard raises their fees, places might stop accepting MasterCard and just accept Visa, something like that. So these guys almost self-control themselves. American Express just charges a little bit more. I think it's actually almost a full % more for American Express. I'm not sure how they get away with it, but they do. Maybe the perks are better. I think that might be a common thing, that some of the frequent flyer miles and stuff like that are better on the American Express side of things. So
don't a lot of businesses use them too?
Maybe for that reason.
Yeah.
You know, there's so much. There might be many business perks where the consumer wants those perks, and the store owner has to like just give in and say, we'll pay a little bit more fees because we want their business. Something along those lines. But in any case, we're trying to at least beat this 2.5%. And without any negotiating with CoinBase, we're going to be able to do it. Okay? But the punchline here is, if we had a good idea, a proof of concept, we could probably go to Coinbase and say, hey, we have a cool idea. Can we talk about that 1% fee and talk it down? Probably could.
Why do we need the Coinbase?
Why do we need Coinbase?
Yeah.
Well, why wouldn't we need Coinbase?
We can just access the blockchain to ourselves.
Oh, okay. We certainly could, but that now we've created a situation where grandma can't go into the grocery store and buy stuff. You know, only people who are Bitcoin savvy are going to be able to do that. What we really want to do is we want to take the complexity of a cryptocurrency out of the consumer side and also out of the store side, and build a payment system in the middle, kind of like Apple Pay. Apple Pay is leveraging the credit card system, but whatever. But kind of like Apple Pay, where it's easy to pay. Company gets their money, person can spend their money, and what happens in the middle, we don't care, as long as it's US dollars coming out of this guy's account and US dollars going into this guy's account. That make sense? So that's what we're trying to create here. So we're going to have a customer, for our example, who has a Coinbase account. So for instance, I have this Coinbase account, and I currently have some fraction of a Bitcoin in there. I can transfer some more in if we want to play with some stuff, but I have my bank account hooked up to it. So what we can do is, if we pretend like I'm going to make a $1 purchase, I will go to, I'll open up my app, if we end up turning this into an app, and I'll say, okay, I need to make a $1 purchase. My bank account's hooked to Coinbase. All right, so if I want to even, whoop. So this is my bank. So bank account, I have a bank account which is hooked to Coinbase for US dollars. All right, we put Coinbase here in the center. You chose a poor shape for. Perfect. Everybody relax. Oh, yeah. Nailed it. All right, so CoinBase is going to do this transaction between US dollars and Bitcoin at a 1% fee. Okay? So, if I'm going to make a $1 US dollar purchase, I'm going to take $1 out of my bank account, filter it through CoinBase, buy $1 worth of Bitcoin. So right off the bat, I just bought 99 cents worth of Bitcoin, keeping with this 1% example. Okay? So I got 99 cents worth of Bitcoin. Then I'm going to use the pre-existing blockchain. So now behind the scenes, we're doing just a Bitcoin transaction. Okay? So now I'm going to use the pre-existing blockchain, and we're going to transfer these Bitcoins, my 99 cents worth of Bitcoin, over to this address. That's the address associated with the store. Okay, the store's account that we're going to set up for them, and we'll see how we're going to do that. All right, from there, we're going to use CoinBase to transfer Bitcoins back into US dollars. So 99 cents worth of Bitcoins come in here. We're back to US dollars. We're stuck with 98 cents now. So we had a 2% loss during the road trip. Okay? But that still beats the 2.5% loss here. So we have a 2% loss, and we're confident that with a real product that we could convince CoinBase to negotiate that 1% down with a bunch of these microtransactions, right? Doesn't really cost Coinbase anything. They already have the system in place. The blockchain handles all the transactions. All we're doing is committing to using Coinbase for all of our conversions. Okay? But in our worst case scenario where we're not even going to make a phone call to Coinbase, we're beating this guy by 0.5%. So the store is going to have their bank account set up. So the store is going to have a Coinbase account, or at least an account with us, and we'll generate a Coinbase account for them, however we decide to actually implement this. So store has a bank account. US dollars ultimately flow into that bank account, just like US dollars ultimately flowed into the bank account up here. Okay, so in our purchase up here, our bank account turned into US dollars, so we may have had them on us. We might have swiped our credit card. We probably did swipe our credit card. We're going to pay that bill with our bank account, so that's where it comes into play. So turned into US dollars. We paid. US dollars on the flip side, Visa, MasterCard, American Express pays the store into their bank account at a 2.5% loss. For us, we're taking more steps here. Bank account to US dollars through Coinbase to Bitcoin over the blockchain to Bitcoin to Coinbase into US dollars back into a bank account at a 2% loss. But if the consumer doesn't see any of this, okay, if this is all behind the scenes to the consumer, and all they had to do is take out their app or whatever and say, oh, $1, scan their little address, maybe it's a QR code or something like that, paid. Done. Kind of looks like Apple Pay. That make sense? Okay, so that's what we're trying to accomplish. So what we need to do, for starters, is we need to look at Coinbase and see how do we turn US dollars into Bitcoin? How do we make that transfer? So here's Coinbase's API. We have already looked at the balance version of this guy right here. Okay, but there's some transaction stuff down here. Here we go. Purchase Bitcoin by debiting your US bank account. So with your Coinbase account, when we establish that, you can hook up a bank account to it. And with that bank account, let me go to CoinBase here, just to make sure. I think we looked at this before, just in case. Okay, somewhere in here I have settings maybe. Well, whatever. Somewhere in here I have it set up so that now, there it is. So here's an E-Trade account I have set up on here. You can currently purchase Bitcoins for a full Bitcoin for $363.07. Let's see. I can buy $50,000 worth of Bitcoins today if I want, but that's not going to really do us much good because anything over 1,000 we have to wait 4 days for. We need instantaneous transactions. So really, I can buy $1,000 worth of stuff using our little method here instantly. Make sense? That's Bitcoins that hit my account instantly. All right. So if I want to, let's do the math here. So 1 divided by 363 is 0.00275. So if I want to buy 0.00275 Bitcoins, that's how many Bitcoins I want to buy, my total fee is, oh, the bank's charging me a fee too. Oh my gosh, this is turning into garbage. We'll have to negotiate a lot of these fees out. We have to negotiate a lot of these fees out. Actually, let me do something interesting here. Let me put in 1 Bitcoin. Fixed bank fee. So probably don't buy something for $1 with this. Or keep a balance of Bitcoin, something like that. So it's a fixed fee, bank fee. So in any case, here's your 1% CoinBase fee. And then there's an extra 15 cents of bank fee on there. But whatever, we can negotiate all that stuff. We're looking for proof of concept. So in that case, I was going to buy 0.0025 Bitcoins or something in that ballpark. That's how much it's going to cost me. At the end of the day, it's going to cost me $1.07 to buy those Bitcoin because of the bank fees. But regardless, if I can make that purchase automatically, then now I have Bitcoin inside my system without them having to go to Coinbase and actually doing the math, blah, blah, blah. So we want to be able to put in a US dollar amount and figure out how many Bitcoins we need to buy to be equivalent to that US dollar amount. Make sense? We already see in the documentation here that we can make a buy. So we can say, how much do we want to buy? This would be the body of it. Remember when we create that message? Part of what we're concatenating onto that was the body. In our current example, we're concatenating on the empty string because there is no body to requesting the balance. In this case, the body is going to be how many Bitcoins do we want to buy? So for instance, you might buy a quantity of 1 Bitcoin. So this is JSON that we're going to be providing as the body of our post request. The response is going to be whether or not the buy was legit. It's going to give you some sort of transaction code, blah, blah, blah. It'll give you all your fees, your bank fee, till it was created, when the payout's going to be. As long as it's less than 1,000 on my account, it would be instantaneous. It would be today. Give you the total and the amount. So this basically is your receipt that the purchase happened. Okay? But before we can do that, we need to figure out what our quantity is going to be. We need to calculate quantity. Okay, well, how do we calculate quantity? Well, we need to know the current price of Bitcoin. So we had currency, show currency supported by Coinbase. We also had our exchange rate. Exchange rate gave us Bitcoins in euros, US dollars, that kind of stuff, right? So we can use this guy here to get us our current value of Bitcoin to US dollar. Make sense? So that we know how many Bitcoins we have to buy. So if we're going to be purchasing something for $5, we now need to find out how many Bitcoins is equal to $5 right now. Get that number, then make a purchase for that number of Bitcoins. Then use the blockchain to send that to the other person's address. Then receive that, turn it back into US dollars at the current rate. Keeping in mind there might be a 10-minute delay there. So you're hoping the rate doesn't change too much in that 10 minutes. Okay, that's kind of the weakness of Bitcoin right now. That's why I'm suggesting that maybe keeping a pool of Bitcoin might make sense on both sides here. But regardless, in 10 minutes after the blockchain transaction is complete, it'll automatically get turned back into US dollars and go into the store owner's bank account. Make sense? So our starting point is we need to, since we're going to make this only work in US dollars, we need to get the current dollar amount that Bitcoins are worth in US dollars at any point in time. We're going to do that using our exchange rate thing. We've already done this one. Let's go back to our code here. Now, let me ask you this. Do you think we can just modify this guy here to give us our, well here, let me do this. Let me copy this line. Copy that. Can we do that and have it work? I know we're not going to be down to the level of US dollars yet, but can we use our get HTTP method that we wrote last time to do a get request for exchange rates? And will it work? So there's all our exchange rates. Now, why was there question as to whether or not it would work? Think about our get HTTP. This is doing all this encryption crap, right? Was that required for the exchange rates? Was not. So we did that before we ever looked at that, correct? So we're sending it some additional information that we did not need to send it. But no harm, no foul, or is it? Are we making it less secure by sending that information? What information do we send along that we didn't have to? We sent along our API key, we sent along a signature, and we sent along a nonce. Is that making this insecure in any way? Is it okay if we give them our public key? Doesn't hurt anything. Is it okay if we give them a signature? It's a hash, one-way cipher. Can't reverse it. Is it okay if we give them a nonce? Just some random number? It's fine. So are we hurting anything here? Other than a couple of CPU cycles to send this extra crap. Not a big deal, correct? Okay. So, let's open up our JSON parser and JSON var. Okay, so JSON parser is going to get the response from that wall of crap, all those exchange rates, correct? And now we have this little method just called display right now that's just dumping it to the screen using our vars. But we might want to request a specific variable. So now we're kind of expanding on our JSON parser code a little bit to give us a little bit more ability to read from a JSON string. So we might say something like this. We have, let me actually do it this way. This takes the opening and closing curly braces. This splits it on commas, right? Then we have this JSON var, and we are displaying each var to the screen. What I'm going to do instead of this is I'm going to take all that stuff and I'm going to put it up here inside of our constructor. Do I want to do that? It's a linked list. Well, let me do this as arrays instead, just so it's at least in the realm of the people who are in 250. So we're going to do JSON var array called the vars. Inside the constructor, we're going to read in our JSON. Then we're going to take the opening and closing curly braces off of it. So we're stuck with just the actual comma delimited variables. Then we're going to get the parts, which are going to be all those things separated by commas. Now that's how many variables we have. So once we have that, we can go ahead and make our array for variables the exact same length. So the vars is equal to a new JSON var array of size, the parts, dot length. All right, so that guy will be the same size. So this just creates a container capable of holding all of our variables, all of our JSON vars. And it's the same number of, it's the same size as we have variables. Now, as we go through all that and we create our var, rather than displaying each of our vars like we did here, I want to add it to my vars array. The vars at bucket I is equal to the var. Okay, so here's our constructor. What does this guy actually do? If we were to concisely say, this stores the JSON string and parses it into JSON vars, storing them in an array called the vars. That's what this constructor does. So at the end, once we've built our JSON parser around a JSON string, what we're left with is this array containing all the variables. I'm going to go ahead and take the display method out of here just for right now. We're going to add another method. The method we want to add here is to get a specific variable. Get the value for a variable. So we're going to say public string get value for var. String var name is what we'll take as a parameter. Okay? Now, if we look at JSON var, that class we had created, we keep track of two pieces of information, a name and a value. Okay? We already built in a couple of methods here. One is to determine whether or not a var name contains a certain string. But we also want to actually be able to get the var name and the var variable. So I'm going to create a couple of methods. Public string get name. This guy will return this dot name. And public string get value. This guy will return this dot value. Okay, so we've given ourselves access to these private variables. Okay, now get value for var takes in a var name, and what we're going to do is we are going to go through all of our JSON vars, looking at the name. And if the name matches the var name that we're looking for, we're going to return the value. Okay? So, for int I is equal to 0, I is less than the vars dot length I plus plus. So we'll go through all of the elements in our array. And for those of you who are currently in 250, arrays are a lot like strings. A lot like strings. Except instead of being a collection of chars, it's a collection of objects. A collection of stuff. In this case, each bucket holds one of our JSON vars. Okay, it's as opposed to a char. So we're going to go through that guy. And each time through, we're going to say if the vars at bucket I, that's kind of like saying char at I. This is the array version of that. The vars at bucket I dot get name, that's the name of that variable. If that guy equals var name, the variable we passed in, the variable name we're requesting, then we will return the vars at bucket I dot get value. If we're still alive here, we'll go ahead and return null. The variable you requested was not found. All right, so this allows us to ask our parser to give us the value associated with a particular variable name. Now remember, we're writing this for simple JSON. If our JSON gets too complex where we have JSON objects inside of JSON objects inside of JSON arrays, which have JSON objects in it, our simplified version of this starts breaking down pretty quick. So simple JSON, which is what we would almost always be dealing with. So JSON is one of these languages that's very powerful for data representation, but very rarely does it actually utilize all that power. Almost always it's a collection of variable value pairs separated by commas. Okay? And that's our case right now with what we're trying to accomplish. Okay, so inside driver, here's our string JSON. We pass it to our parser, so we have JSON parser JP. So now we're going to ask JP, so we'll say system.out.println JP dot get value for var. Now, we need to find our var name. And I don't remember the variable name, so what I'm going to do real quick is I'm just going to take this URL. I'm going to paste it into a web page so we can look at the var names real quick. Okay, and I think what we want is BTC to US dollars. BTC underscore TO underscore US dollars. Okay, and we'll print out just that value. Go ahead and run this, and there is current price of Bitcoins in US dollars as a string. Make sense? Because this is the variable name we're looking for. This guy read in all those different variables, and one of those was this particular guy. Now, we could actually go US dollar to BTC. 1 US dollar to BTC gives us that number. So we can also take that number and multiply it by the amount we need to buy. So if we have $4.27, so 4.27 US dollars, and we can multiply it by that, that tells us how many Bitcoins we need to get. Correct? So this guy's a string. So if I store double US dollars is equal to $4.27, so 4.27. Then I'm going to say double US dollar to BTC is equal to double.parse double of that. That will turn this string, which is our point whatever, blah, 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 into a double. Just like integer.parseInt, except this takes a string representation of a double and turns it into an actual double primitive type. Now we can print out here, we'll put a nice little $sign in front of it. US dollars concatenated with in BTC is US dollars times US dollars to BTC. Go ahead and run this. So $4.27 in Bitcoins is 0.0118022, blah, 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 blah. So if we were doing this transaction, that is what we need to buy from Coinbase. That's how many Bitcoins we need to buy from Coinbase. Make sense? Okay, we'll come back on Monday. We'll finish doing that conversion, and then we'll actually make a purchase using my money, live in class.
On YouTube.
On YouTube.
Secret key. What are you going to buy?
That is true. That's an excellent point.
We were talking about that last time, right?
That's a very excellent point. And then they can send it to their own Bitcoin address.
Yeah. And not traceable.
Totally awesome.
$50,000.
I guess we're just going to go with it.